we are going to study a very interesting property of the sigmoid function that we have just erased this term. So it's something like this, right? Remember, conventionally we present a sigmoid function in this form, that is sigma of x. Since the name is sigmoid, that's why we use this sigma function. Okay, so sigma of x means something like this: 1 by 1 plus e to the power minus x. Now the interesting fact is that if you try to find a derivative of this function, that means derivative of z with respect to x. With respect to x means with respect to the input, because we always find the derivative with respect to input, right? We have also seen in previous cases like linear regression that we are actually finding derivative of error with respect to the inputs. So dz dx, if we consider, what which basically represented in form of sigma dash x, like this, it is something like this: d dx of 1 by e to the power minus x, I mean 1 by 1 plus e to the power minus x. Just I have just represented this term by to the power minus 1, so it's same actually, right? So let's do one thing, let's try to find a derivative of this. Just we will do the computation. You see, it's a simple chain rule we are applying here for the derivative, right? We're applying like ddx of something, so that x to the power minus 1, that means x to the power minus 2 into something. So it's like minus 1 plus e to the power minus x to the power minus 2, obviously, multiplied by derivative of the actual this one with respect to x, right? So let's proceed further. You see, here we can find the derivative of the first part and the second part individually. And you see, the first part is the constant one, so derivative of constant is 0, you all know, that's why 0 plus, again we can apply a chain rule, like derivative ddx of e to the power minus x, that means e to the power minus x, then ddx of minus x, right? And the this side remains same, there is no change here because it's already outside the derivative. So as a result, what will happen? We will see the result something like this, right? As a result from the whole thing. Now you see, just trying to make it in a different way. What I am doing, I am actually doing like, we have here 1 plus e to the power minus x to the power minus 2. That means 1 by 1 plus e to the power minus x square. And that's why I have written 1 plus e to the power minus x multiplied by 1 plus e to the power minus x separately here at the denominator. And in the numerator, we have e to the power minus x, definitely, where e to the power minus x I have written as 1 into e to the power minus x. And I have added with 1 and also subtracted by 1. So as a result, it remains e to the power minus x, right? So what you can see from here, that we have actually added several terms in this equation which will be basically cancelled out within each other, and ultimately we will get back the same. Now question is that what is the necessity of erasing this term 1 here and again minus 1 here? Why I have done this? Because we want to now divide the whole thing into two parts, something like this. In one side we can say that okay, it's 1 by 1 plus e to the power minus x, this part, and in another side we can say okay, e to the power minus x, okay, plus 1 minus 1. Fine, that's okay. Now, so what is the benefit we will get? Let's see. If we just try to continue recreating this equation in a different way, what I can say, okay, let's do one thing, let's let's separate this part and this part. I have done this actually. So what I have done, I have just written 1 plus e to the power minus x, this one, by 1 plus e to the power minus x minus 1 by this. Obviously, I've done some step jump, a very small step jump although, but what you can do, you can try in your home and you will see that if you just, you know, subtract this one from this one, just simply subtraction rule, you will see that you will get this particular term. Okay. Now, what benefit we will get here, that you see 1 plus e to the power minus x is present in numerator denominator both side, right? So it will cancel each other and I will get 1 as a result. And here I have the same term that I have here, right? That you can see. So as a result, what I can get, what I can see, I can say that okay, it's 1 by 1 plus e to the power minus x into 1 minus 1 by 1 plus e to the power minus x. And what is this 1 by 1 plus e to the power minus x? Already we know that 1 by 1 plus e to the power minus x means sigma of x, right? So that means as a result, it will be sigma of x into 1 minus sigma of x. That means this is nothing but the derivative formula, which we started from sigma dash x, right? We ended here sigma dash x, which is equal to sigma x into 1 minus sigma x. That means, so what we can conclude from this point is that the derivative finding of a sigmoid function is very easy and very computationally efficient. That means in future, when we will create a very complex machine learning model, you will see that you will need to activate some set of points, based on some input, and that activation requires some threshold, right? And that threshold can be decided by the sigmoid function. And why exactly sigmoid function again I'm saying? Because when you will do the corresponding mathematics, you will see that since finding the derivative of sigmoid function will be very easy, that's why corresponding cost function and the error function will become very easy to compute for a computer, which will be a very good thing for us. So this is why sigmoid function is very vital for any machine learning model.